And for our next example, we're going to look at finding the volume of a sphere of radius c using a triple integral. You may have done this in Calculus 2 as a solid revolution. This is as a triple integral. The hard part likely being the setting up our triple integral, because our function is just going to be f of x, y, z equals 1.
Well?
Yes, that's right. So the tricky part is finding our limits of integration. So let's think about what would z be. Well, our sphere is x squared plus y squared plus z squared equals c squared. So that is our sphere, and I would say upper limit for z would be the top. And so if I solve this for z, I think you could probably see I would get z equals c squared minus x squared plus y squared, x squared plus y squared grouped. And so then one more step, take the square root of both sides, we'd have z equals plus or minus square root of this, right? So that would give us a top and a bottom, the top being the plus, the bottom being the minus. So then we'd have to say, what about this circle? Well, this circle is x squared plus y squared plus z squared equals c squared. And so if you looked at it, it's x squared, no, there's no z, I'm sorry, x squared plus y squared equals c squared is the circle. And so solving for y equals square root of plus or minus square root of c squared minus x squared. And then x would be going from negative c to c. So I think you can see our limits of integration based on our discussion of what makes up this. So that would be our integral to find the volume of this sphere. But I want you to keep in mind we'd like this to be as simple as possible. So let's just find the volume of the sphere in the first octant and multiply that answer by 8, because there's 1, 2, 3, 4 eighth spheres above the xy plane, and 4 above the xy plane and 4 more below, so it'd be 8 times the first octant. And so you could probably see, using symmetry, we can say it's 8 times z going from 0 to the square root of c squared minus x squared minus y squared, y going from 0 to c squared minus x squared, and x going from 0 to c, and that covers us the first octant, and the 8 gives us the entire sphere. Now, integrating this with respect to z is a piece of cake, because integrating 1 you just get z, and this z equals 0 is a lower limit, so that won't have any effect on the integrand, and the upper would be this. Now suddenly we have a serious difficulty. Integrating this with respect to y would have to be done with some kind of awful trig substitution, and I don't feel like going there, and I'm sure you don't either. So at this point, a quick conversion to polar coordinates, okay? And then our dy dx changes into r dr d theta, and our x squared plus y squared is now just going to be r squared. Our r value is going to be 0 to c. Think about across our circle, outer radius is c, inner radius is 0, and we're in the first quadrant now. And so theta going from 0 to pi over 2, we still have our 8 out here. So this is doable, because if you let u be c squared minus r squared, then du over negative 2 equals r dr. So therefore we wind up with 8, our limits of integration. Now since we made a little change here, r was going from 0 to c, and so if r was 0, our u limit would be c squared, and if r was c, then our upper limit would be 0. But that's easily fixed since we got a -2 in our denominator when we substituted du over -2 for RdR, and that factoring out that negative switches out our limits of integration from 0 to c squared. And now we can integrate this with respect to u. That's just u to the 1/2, so that's 2/3 u to the 3/2, and the 2 in the 2/3 cancels with this 2, so we wind up with this. Don't forget the 8 still there. So c squared, well, when we put in 0, of course we get 0, so c squared to the 3/2 is c cubed. So we wind up with c cubed over 3 d theta, all times 8. So we got 8/3 times pi over 2. When we integrate this with respect to theta, theta's the c squared, the c cubed over 3 is a constant. So we get a theta going from 0 to pi over 2, so we wind up, when you put in 0, you get 0, so we wind up with 8/3 pi over 2 times c cubed, which is 4/3 pi r cubed, just like we'd expect.